begun recording. Give me a second. So I've just begun recording, and I've put this in the text box that if you do not wish to be heard or if you do not wish to be seen, please make sure that at all times your camera and your microphone are turned off. And I've put that in the text box. Well, you can find the camera and the mic right on top right hand side of your screen. So if you just, I think it is off now, so don't touch it. It is off now. Right, so welcome to University of East London. It's a sunny day. I'm live streaming from my kitchen, and I've never done this before. It's quite exciting, and I've never done these experiments before too. So we will see how it goes. Fingers crossed. But I think we'll have an exciting 1 hour time. So at some point, if you are happy, you can unmute yourself. I ask some questions, you fire away. So the way I like to run this session is that I'm going to do a number of experiments, and I may ask you, what do you think I'm going to get in terms of results? And you may say, well, it should be higher, it should be lower, and then I will do the experiments and we'll see why it was lower or higher. So there is no right or wrong answer. I like you to get engaged with me, and it's in a way good because it's supposed to be a very, if you like, interacting. Yes, can you Roshan, I think you can hear me. I think you can hear me. You should be able to hear me. Can you hear me, Roshan? Yes, Roshan, you ask a tricky question. Is anyone speaking? Can you hear me? Or any other? I think Muhammad, you gave me a thumbs up, so you can hear me. Oh, thank you very much, Tulaksan. So yes, so now I think now I understand your question. You can speak. Yes, if you like to speak, you just need to unmute yourself and speak up, and that's what I like to happen. So let's begin. I'm gonna switch my camera, and there we go. I'm gonna move my camera a lot today, so good. So bear with me. Welcome to my kitchen. So we are going to talk about soils. We are going to talk about foundations. We are talking about building on soils and all things that you have got to consider before beginning building on soils. So let's have a look to my kitchen, see what I have for you today. So, you can see here that, I have a bit of monkey beans, and I'm not a big fan of this game, but yes, I have some houses here. I've got some houses here, a car here, two buildings, and I've done this just to tell you that, well, whatever you want to build on the ground, and that will be your job as civil engineers. It will start with a foundation. If you want to construct a building, if you want to build a bridge, a road, a house, you've got to build these on the ground. And that's why we are going to talk about the ground and soil a lot today. Now, I do not have soil, natural soil with me today, but what I have is something that can simulate natural soil. So let's see what I've prepared for you. I've got some black-eyed beans, I think, peas here. I have some mung beans here, and I've got some this is bulgur, so it's like couscous. It's very fine. I've got some ground coffee here. I also have some lentil there. So I have a number of experiments. I'm going to talk about soil strength, and we are going to measure the strength of soil, and this is something exciting. I have the Eiffel Tower here for you on well, on porridge really, but porridge is simulating, let's say, fine grained soils, and I've got some mung bean at the very bottom, which kind of simulates the sand and the gravel. I'm going to talk about all of them. I have a very simple model of foundation here for you. I can wet the foundation, I can load the foundation, I can build on the ground. It's a clay ground. And well, I have a dummy robot here for you because it's going to sit on the ground. Oops, it's going to sit on the ground, and I'm going to show you what sort of hazards the ground can cause to the built environment. But let's begin with soils. So soil, unlike timber, unlike steel, unlike concrete, is a complicated material. Soil is formed of grains, air, and water. So let's see what we have in terms of soils. So soil is made up of grains, water, and air. When it comes to grain, the grains can be, let's say, 2 millimeters in size, like this, and that is known as gravel. You will get gravel from any builder. You can get gravel from any builder, and also in coastal areas. And that's quite, let's say, coarse. Each grain is about 2 millimeters in size. You can have a little bit of finer types of soil, and that's called sand. Well, I've got some mung bean, and yeah, so you can get sand if you walk on beach, and it's quite pleasant. Soil can be even a bit more finer, and it is called silt. So with silt, well, you can kind of feel the sharp feeling if you kind of put the silt between your fingers and rub, but you cannot really see the shape of particles with naked eye. That is called silt. And then you have clay, and clay is the very stuff that you will get in your back garden. I have some ground coffee, and it kind of represents clay. The particles are extremely small, and it's very water friendly. It absorbs the water. And soil is really a combination of gravel, sand, silt, and clay, which sits together, form some empty spaces, which may or may not be filled with air and water. And that is what soil is made of. You may also have some salts, and these can be carbonate, these can be any form of salt. I've got some table salt here, and salt can be in the size of clay, but it can be kind of found in soil too. So soil is made of all these particles and void spaces and let's say water. To build on soil, you've got to make sure that the soil is strong enough. Now, the silt and clay are the very type of soil that you will get in your back garden. Gravel and sand are the very types of soils that you can get in from the builder or in the beach. But since London is pretty much built on clay, I'm going to talk about clay a lot today. So let's see if we can measure the strength of clay in order to design our foundations. I've got some clay for you here, which is basically ground coffee. And to build on the ground like that model, well, you've got to make sure that the ground is stiff, and by that you have got to make sure that you get rid of all the void spaces, all the air which is inside the body of the soil, because you do not want the air there. You want all these particles to remain in the soil and no air whatsoever. And that's why you can see these very noisy compacting machines if you travel to the city, and they are banging the ground and getting the air out of the ground, and it's known as compaction. So I'm going to do compaction today in my kitchen. I do not have clay, but I've got some very smelly, very good ground coffee. Now I want one of you to unmute yourself and tell me whether you expect me to mix this ground coffee with water before compacting it into these mugs or not. Will it really help? And if it helps, Would you like me to add a lot of water, a little water, or somewhere in between? You can put it in the text box. So I'm gonna watch my text box. What would you expect from me? So I'm going to compact my kind of ground coffee with a pestle. But what do you think? Shall I add water or not? You can give me a thumbs up if you think that I should add water. Or you can put something. I can see Faria. And whilst Faria is typing, you can also join. What do you think? Shall I add water? If I should, how much? Little, a lot, somewhere in between. And then I'm going to do it for you. And we will see where we go. There is no right or wrong answer here. So be confident in what you're going to say. So whilst you are, so add a small amount of water. That's good. And it's not wrong. It is not wrong. I can tell you that it is not wrong. So let's see how this can work. I am going to make my tripod a little bit shorter in a moment, like this. So bear with me. And there we go. There we go. And there we go. So you can now, I think, see my desk. Yes, you can see it. So let's see whether adding a little amount of water to my ground coffee or my clay is going to help me or not. I've got a scale, I have got my ground coffee, and I've got 4 mugs. So I can tell you that I have something around 200 grams of clay here. I'm going to put it on my scale. So I'm going to start with just a little amount of water, just like what Faria told me. I've got some water here and a little water. How much is little? 25 grams. Let's begin with 25 grams. So, well, I added 31 grams. That's fine. 35 grams of water. And I'm going to add my water to my very good smell, if you like, ground coffee, and I'm going to mix it, and then I'm going to compact it in one of these little mugs, flip it over on my scale and load it to see at what force or at what effort my, if you like, my sand castle may fail. So just a little water, as Faria suggested. And then I'm going to add a bit more water, then a bit more water, do this experiment, and then we will get to our foundation exercises, which are going to be very exciting. So I added a little water, and now I'm going to fill my mug. I have 30 grams of water in my 200 grams of soil, which is basically coffee. I have a pestle, so I'm going to kind of compact it gently. Let's see where we can go. Another layer of good smell coffee, which is basically representing my clay in my back garden. It's the very same stuff, to be honest. Yeah, the minerals are different, but if you learn physics during your course, you can be anyone you wish to be, because engineering is all about physics, and a good engineer is someone who understands physics very well. You can be anyone you like. Yes, you will be a civil engineer, but you can be anyone you like because you are good in physics. And civil engineering is all about physics. I remember when I was a student, I had civil engineering peers who are now even mechanical engineers, or some of them are working in insurance companies, some of them are working in finance sector. And that's the beauty of civil engineering, because all sectors in industry need civil engineers. So, and the last layer, all nice and good. I'm all ready. So, hold your breath. I have my scale, I have my, probably you won't be able to see my scale, but trust me, I'm gonna tell you exactly. So, I've got my scale, and I've got a foil on top of the scale because I do not want to lose any coffee. I'm gonna use these coffee beans again, ground coffee, and I'm gonna flip my, if you like, sandcastle like this. You can see that it is very fragile, so the strength is very little. So that is not a good sign. But let's see whether I can get any decent sandcastle from this. It's strong enough for me to load test it. Well, you can see that my sandcastle is very fragile. Why? Because I just added a little water to it. And this reminds me of when you are traveling on beach. You have the dry sand and you have the wet sand. As you get closer to the shore, you can see that the sand is quite sticky and it can give a shape to the sand. But as you get far from the shore, you will see that, well, the sand does not have any real strength. And this is the story of my clay castle. It was very dry, so I couldn't really manage to get any form of strength from it. What I'm going to do now is that I've got my scale here, right? And I'm gonna bring back the reading to 0. I'm going to add, well, this dish on top, and I'm gonna press it until it fades. There we go. So really, I got 10 grams of force. I only managed to apply 10 grams of force before all this very dry, if you like, clay castle failed. So my coffee beans was, well, my ground coffee was very dry. This time I'm going to add a little bit more water and see whether I can get a greater amount of strength or not. So there you go. Let's see how I can, or fail to can, if you like, increase the strength. So the first exercise told me that a very dry soil, which is clay in your case, does not have a lot of strength. Even if your soil is clay, even if your soil is that genuinely sticky material in your back garden. So this time I'm going to add a little bit more water. This time I'm going to add 50 grams of water. So I had, I think, about 30 grams. And now I'm adding another 50 grams to my soil or my ground coffee. I'm going to mix it. Mix the water and my ground coffee. And this time I'm going to build my, if you like, clay castle or coffee castle and load test it to see whether higher amount of water can help me to get a better strength. I think it's quite good. Let's see. Layer by layer, and I've got my pestle so I can compact my, if you like, ground coffee. I can already see that my coffee is getting compacted better. So water appears to be helping. Water appears to be helping. What I'm doing effectively is that water is lubricating these coffee grains, and the coffee grains are, if you like, sliding on top of one another. And as I'm using this pestle, just like the builders in the roads and with their really noisy machines, I can manage to get more air out of the soil as my material. So, to be honest, I'm expecting to get some decent strength. Good, good. So filling it up. There we go. Making sure that it is flat and nice and compacted. The moment of truth. Let's see what we can get. This time I'm going to show you the scale. Okay, so probably for now, turning this off.
Hi. Sorry.
Yes, Sean.
This session has been moved. The link is actually in the chat.
Okay, say again, Sean.
Then there's a link that's redirecting people.
There is a link in the chat. I cannot find any link. Shall we go to another room?
Let me just send again. So, oh, it says I can't. Okay, 1 second. I just have to go into a different.
Okay, so whilst Sean is oops, sorry. Let me switch my camera. So whilst Sean is looking for the rooms and the teams of many rooms, let's see what we can get. Yeah. So let's get a better, closer look to my. So this is quite nice. This is quite nice. Ready for load testing. Let me see if you can. Is this what? Yeah, good. So, let's do it. I'm gonna bring back the reading to 0, and I'm going to put my, well, dish on top. Okay, it is already 150 grams. Let's do it. 300, 400, 5, 7, 8, 1,000. Oops, about 11,000. It went between 10 and 12, so about 11,000. Keep it in your mind. That was 1,100, not 11,000, 1,100 grams. 1,100 grams. And you can see that my sand castle this time, or my clay castle to be more precise, failed in a very nice kind of sheer mode, and that's what I'm really expecting. So let me move. Okay, good. So now this time. So keep it in your mind, 11,000. Can you see me? Probably you can. So it seems like that when I increase the amount of water in the soil, I manage to get more air out of the soil system, and I manage to get a higher amount of strength. But is this always going to happen? Shall I say, well, I can add any amount of water to the soil and increase the strength of the soil forever? What do you think? This time I'm going to add a little more water. Probably this time about 67 grams. 67 grams of water. So you can see that I'm kind of now turning into a slurry, a mud. And to be honest, even working with a slurry for builders is extremely, extremely hard. If you are designing an embankment, if you are designing a road subgrade for, let's say, HS2 or another project like that, even if you manage to get a high amount of the strength by adding a high amount of water to the soil, you've got to consider how workable your design is, and if really the contractors can implement the design, can execute the design on site or not. Good. It is, I'm not even adding all my water because you can see that already it is a slurry. And now I'm going to fill up this is the last experiment of this sort, and then we can move on to the foundations. Now I'm adding my very, very wet, sticky ground coffee. I'm putting that in my mold or in my mug. What is happening here is that as I'm compacting the clay or my let's say ground coffee, you can see that a layer of water, a layer of very muddy water is standing on top. What is happening is that water used to lubricate these particles and get them to compact better, but now it appears that as I'm compacting my soil, water and soil particles, or in this case coffee, is getting out of the ground. It's making the ground lighter, and that is really not what I'm wishing. So there is a good chance that I get a lower amount of strength than what I got in my previous step. But we've got to check it, obviously. It is an experiment. It is an experiment and we're going to check it. I don't think I'm going to have this coffee for my breakfast tomorrow. Okay. Yeah. There we go. Again, this time I'm going to put my scale in front of you so you can see it. And my foil here, and I'm going to flip my sample, if you like. Okay. So last time you saw what a beautiful clay castle we got. But let's see if we can get another beautiful one. Here today. It is very wet. And okay, so you can see that I'm getting something just like the first experiment. The only difference is that in the first experiment, the clay was too dry. It couldn't really stand. Now the clay is just too wet, and it's really the same business. I'm going to make this scale 0 and put my, let's say, my foundation on top. You remember that we got 1100 grams of strength in the previous exercise. This time I'm going to load it and see what I will get. That is 200, 300, 4, 5. That is 7. Oops. Well, you can see that before I got to 1000, I got the very same type of cracks in the body of my sandcastle, and that means that my sandcastle, my clay castle, is again failed. So let me put my camera back here and so what we learned here is that water is not always our friend. We need water in order to compact the soil and build our foundations and buildings and bridges and roads on the ground. But if we add too much water to the soil, then the strength will come down. To some extent, water is our friend, because to some extent, water acts like a cooking oil. It lubricates the grains and helps them to slide on top of one another and get the air out. But if you add too much water to the soil before compacting the soil, then it's not going to help you. So the message to this end is that water is not always our friend. And now I can move to another exercise. I think you can see this probably, and you can see me. What I have here is really a vase. My vase is filled with the very same ground coffee that I have here, but it's very dry. And on the bottom I have some, what do I have? Yes, I have some mung bean. So I've got mung bean, which is like sand, and I have ground coffee, which is like clay on top. You can see that I have a tube, a rubber tube, which is lowered into the mung bean. So by this syringe, I can wet the soil if I need to wet the soil. And you can see that I have a ruler here, which can measure the amount of which my building on top of the ground can settle, can subside. You probably, if you're living in Essex like me, you probably have seen a lot of diagonal cracks on the walls, exterior walls of buildings, or even inside your buildings. I mean, I have some of these cracks in my home. I have some here. And these cracks are all because of settlement. All houses, all buildings in London are founded on this very kind of fine material, clay, and they subside. And subsidence is a big problem. That's why insurance companies are earning a lot of money from it. Anyhow, so let's do it. Let's assume that this is your building, and let's assume that this is your soil. What I'm going to do is that I'm having a dry soil. I'm going to put this building there on top, and I've got some coins here. Some of these coins are 50 grams, some of them are 30 grams, some of them are 20 grams. So I'm going to load up my building, and I'm going to see what happens as the load goes up, as the weight of my structure goes up. What do you think will happen? Do you think I will get more subsidence, more settlement, or less subsidence, less settlement? If you think that I can get more subsidence, give me a thumbs up or put something in the chat box. I have 3 questions, so it's the first question. This is the first question. The first question is the easy one. Then I will move on to the second and, well, third question, which are more complicated. So, Faria. So I'm going to increase the weight of my building. Let's say I have a building, I'm going to build a, I don't know, do a loft conversion. And loft conversion always seems like a very, I don't know, very a harmless activity. But let's see what will happen in terms of settlements and cracks all around my building. So that's the first question. I think you know the answer to this question. You're just shy to say, well, as you increase the weight of your building, you will probably get more and more settlement. What about wetting? If I get in a very wet day, and if the ground gets full of water, fully saturated, would you expect my building to settle more or to settle less? To go more into the ground or less into the ground? That's the second question. And the third question is this. Let's say you have a rainy day and your building is already there with the loft conversion and you have some degree of settlement. What happens if I allow the water to drain out? That's why I have this P-Rex at the bottom, because I don't want to make my wife completely mad. So it's, I'm trying not to wet the surface. So I'm going to open the drain and allow the water to drain out. The question is this: what will happen to the settlement after I allow the water to get out of the soil? Let's say a dry day following a very, very wet day. So these are the things that I'm going to do today. So I've got my roller here and I can measure the settlements. So I'm going to put my foundation on top and I'm going to begin with 50 grams coins. So the settlement is obviously 0. And this is my reading is on, I can tell you that my reading is on 95. So there we go. I have now 96. Sorry, I have 94, so 1 millimeter of settlement. Still 94, 1 millimeter settlement. I have 1.5 millimeters. So I'm now going to continue with 30 grams. I have 2 millimeters. I'm going to continue with the 30 grams. 2 millimeters. 2 millimeters. It's interesting. So the settlement increased from 0 to 2 millimeters and then it stopped. It doesn't appear that 2 millimeters, 2 millimeters, 2.5 millimeters, and I'm going to add a bit more. Two and a half millimeters. So the first lesson is this. I was thinking that as I add a lot of load on my foundation, on my building, on the clay, I will get more and more settlement. This didn't happen. Instead, immediately I got some settlement, and that was as little as 2 millimeters, and then it stopped. So that's interesting. It shows me that if I build on a clay type of soil, which is the very type of soil in London, and if I keep the soil dry, if I make sure that my sustainable drainage systems are working, if I make sure that the water, the precipitation water from rain, the groundwater is very well controlled, then probably I'm not going to have a lot of problems with my building. But the problem is that we are living in London. We are living in the UK. We cannot stop the rain. We will get as many as you like rainy days, and it is a problem. And our sustainable drainage systems are not always as effective as we wish them. So that is something that I've got to see. I've got to check here with my little model to see what will happen to my building. Although my building is seemingly is good, I have done my loft conversion, if you like, and I only had 1 more millimeter of settlement. So although it appears to be functioning good, but what will happen to my foundation and to my building in a wet day? So let's see. I have my piston and I'm going to make a mess now. So I wish that you can see this, and let's see if you can. Probably. So there we go. Let me have a look too. Probably yes. Yep, better. So let's see. I have my tube, which is connected to the bottom of the clay, and that is the mung bean. And on top of the mung bean, I have clay, which is basically ground coffee. And so let's do it. Let's begin. So you can see that I am, can you see the water? The water is getting up the system, and I can see my roller now. I can see that the settlement is getting more and more. I need probably a little bit more water. Let me add a bit of more water to the soil system, this time from top. Allow the water to seep in. And you already can see that I'm getting, now you probably can't see it, but I can see that I'm getting more and more settlement. And it's not happening quickly, it's not happening rapidly, it's happening slowly, but it looks like that the building is going in. And let me show you how the building is sinking in, because the big problem is not settlement. Yes, I'm getting more and more and more settlement, but it's not the main problem. The main problem is the shape of my building. You can see that the building is tilted. The building is kind of inclined to one end, and that is the reason behind these diagonal cracks. you probably can see these diagonal cracks. This is my utility, and this is the door frame. And you probably can see these diagonal cracks. I've tried to fill them, but they are opening up again. And if you go into the utility again, this is my utility, I can see the very same diagonal cracks here, right here. Why? Well, the reason is simple. The reason is this. The building on clay does not always settle at the same pace all around the building. No, it settles more at one end and less at one end. This is known as differential settlement. And the bad news is that it doesn't happen instantaneously. It takes time. It may take 50 years, 100 years for a building, a detached building, a semi-detached building, a two-story building in London to complete its settlement. So you will get these cracks every year. That's why last summer, I tried to fill these cracks with kind of a filler, but then they are opening up again. And these are not plaster cracks because they are beginning from the very corner of my door frame. As an engineer, I know that these are not plaster cracks. These are the cracks that, well, I should be with a low tone because I don't want to make my wife worry, but they are structural cracks. The building is settling, and this is a problem. It's not going to destroy the building, but it is a problem. And the reason is this, because of differential settlements. Any building on clay, if the foundation system is not designed to its precise level, then you will have differential settlement, and you will have all these cracks in the exterior of the building and also inside your building around your door frames. So water is not always your friend. Water can be your problem. Oops. So here in the second soil model, what you have is a layer of sand. And let me see if you can see this. You can. So,
excuse me.
Yes.
So, if there was pile foundation, would this still happen just at a
That's a very good
scale?
question. No. So, I have brought this. These are representing pile foundation. What pile foundation? There are two solutions to this. One, even if you decide not to use a pile foundation, you can decide to use what is known as mat or a spread foundation, and these are concrete foundations that cover the entire area of your building. Now, if you choose to go for a thicker mat foundation, about 2 meters thick, 1.5 meters thick, then you will not have this problem of differential settlement. But guess what? My building here is not based on those mat foundations. Each column in my building is sitting on one independent foundation. Now, if I have a small cube foundations and one goes down more than the other, then I will have this problem of cracking. But as you said, pile foundation is another technique. So let's say you have a poor quality soil or a problematic type of soil, but you know that at the very bottom of your soil, like here, I have lentil, I have a better quality type of soil. So piles are, if you like, buried columns. You put in pile foundations into the system, and then you put your building on the pile foundation, and what it does is that it transfers the load of superstructure to deeper depths. So you will bypass the problem. Pile foundation is very popular in London, but also particularly in East London. If you have traveled to University of East London, if you are traveling on DLR, you probably will see a number of huge building sites. All these tall and high-rise buildings are based on pile foundation. It is because of settlement, because of the exact problem. The groundwater in East London is very high, probably -2, -1 meter below ground level, and the soil in East London is extremely poor quality because, well, it's not even soil. 7 meters thick, so up to 7 meters thick in the dock, in the royal docks, the soil that you will get is a transported material which was transported to the site about 100 years ago, 120 years ago. These were all shipping docks, and they are now filled, well, 100 years ago they were filled with soil, but the way it was done was extremely poor. They are not really well compacted, and the soil in East London is quite variable and quite weak and quite fine in terms of size, like my silt and clay. So pile foundation for any building, I don't know, more than 5-6 story high in East London is a must. So yes, spot on. You mentioned it quite nicely. Going back to my exercise, and I'm aware of time, I have just a few minutes to be with you. I have a layer of sand, and it's bulgur or something like couscous. It's a delicacy like rice, and it's very loose. And I have a dummy, if you like, robot on top. And I have a bottle of water. The bottle of water is connected with this tube to the very bottom of this if you like, let's say, soil model. And what I'm going to do is that I've got some lentil at the very bottom. I'm going to flip my bottle and, if you like, simulate a spring right below this loose sand. What I'm hoping to get, and probably I won't get it, is what is known as quicksand. You will get a lot of quicksand in London, mostly North London, but also the wider UK. Quicksand is a phenomenon when you have a spring at the very bottom of a layer of sand or a layer of silt. This spring boils and boils and boils and goes from down to up, and it reduces the strength of sand, and all of a sudden the sand goes down, sinks in, and whatever building you have underground will sink in. If you look into Japan, and Japan is a seismic active area, and all buildings in Japan are based on sand, this kind of sand. An earthquake is one reason behind formation of quicksands. The recommendation to people during the earthquake in Japan is not to run down the buildings and escape on the road, is going up to the roof and waiting for help. The reason is that when earthquake hits the ground, which is very sandy, which is very loose, and which is very wet, the sand will instantaneously lose its strength and the buildings sink in. So if you are living, I don't know, at floor 16, at level 17, you won't get enough time to get to the ground floor and escape to the roads, to the street. You can't do that. By that time you are sunk. So you've got to go up, stand on the roof, and the helicopters will pick you up. So, am I going to model it here today? Probably not, because you know what? This is not sand. This is bulgur, and it's not quite like sand. But well, let's see how it happens. So, if you're ready. Oops. I can't see the water, but yes, I can see that the water is boiling in. And you already, okay, yes, I can see that. There's some movement in my dummy robot. And you can see that my dummy robot is sinking in. It's not quite as I was expecting, but yes, normally I would expect a sinkhole to happen and my dummy robot to be sinked in. Apparently couscous is not, I could see some degree of sinking, but not what I was hoping for. And on that account, in the next few minutes, I'm going to my very last exercise. I have the Eiffel Tower. Can you see me? Probably you can. So you probably have heard about sinkholes, and sinkholes happen a lot in London and all across England. Southeast mostly. And let's say I have my building on top. What I have is some porridge, and I have some porridge, and I have some mumpkin at the very bottom, but the porridge is mixed with salt. You remember that at the beginning of the experiments, I said you may get some degree of salts in the soil, and it kind of varies between 10 to 20%. And when the soil becomes salty, you will have a problem known as collapsibility. The ground may collapse, the ground may sink, and you get a lot of these problems during January, February time. We had a few incidents in February, not in London, but in the north and northwest, and these are known as sinkholes. If you go to Google News and put in sinkholes, you will see what a huge problem sinkholes are to the built environment. So what I'm going to do, because I know that my ground is a little bit salty, I'm going to add a bit of water to the ground and see what may happen. So you can see that I'm adding a bit of water to the ground, and it is I need a bit of more water. Okay, you cannot see it because you have got to be very close, but I can see that the ground or my building is now sinking in gently. And that's because the salt is getting washed. And as the salt is washed, now the problem with my model, you can see that it's even tilting. The problem is that the ground is getting, the salts are getting washed. But if I had kind of a valve here and was allowing the water to get out, the salty water would have been allowed to get out and replaced with fresh water, and you would have seen that the entire building would have sunk as a whole into the ground. So this is a POX, so I cannot drain out the water, but I can already see that I have tilting and a lot of settlement, and that is purely because of the salt being washed away. So the short lesson really from today's experiments is this: to build underground, it's stretching my tripod, to build underground, you've got to mix the soil, the dry soil, with some amount of water. And let me set up my tripod. Good. With some amount of water. But then the question is how much water? If you have a salty soil with 10 to 20% salt, then you've got to reduce the amount of water that you've got to add to the soil before compaction. If you have a loose sand of this sort, then again water cannot be purely in your favor or work in your favor. But even if you have a clay soil like my ground coffee there, it doesn't mean that water can help you to lubricate the soil grains and get the air out and get a higher strength. No, it will do to some extent, but then after that, you will lose your strength and you will end up in a very muddy, not workable material, which is not gonna really help you. So that was my exercises today. In my kitchen, I did my best I didn't put my hat, forgot to put my hat, but I can do it now. So, any questions?
Would vibroflotation work?
Vibroflotation is a very exciting technique which is used in the Gulf area, and it is extremely, so what it does is that you have rods which are installed into the ground and they vibrate. You either will replace this very kind of loose sand which they use for land reclamations, even in Holland, in Netherlands, to replace it with gravel or to densify it. It works, but it's extremely expensive. The other problem is that it induces a lot of vibration, so you cannot use it in heavily built environments. So for a land reclamation, a new, let's say, land reclamation project in Dubai, in Qatar, or offshores in Japan and Netherlands, yes, you can do that. Very expensive though. Good question. I like your question. Good question. So I think it is now 11:19. So I've eaten my time, and you all guys, you have got to go to the next session. So I'm not gonna. Sean is typing something. So I will be available on this question and answer unibody system. So if you have any questions about your course, I'll be there to answer to your questions. Thank you very much, Sean. So Sean has put a text message here. Please go to this link and make your way to the next room. Sorry I ate some more of your time, but I hope that you enjoyed my experiment. Take good care, guys. Bye-bye. Bye from my kitchen. Thanks. Bye-bye. Bye all.